Okay, so when you're looking at the nuts and bolts of an ellipse, and again, these ellipses, we're just going to start by looking at having a center 0, 0. And so when we do this, there's really two options. And so for both of these, you're going to have a center that is 0, 0. The first one, our foci, are going to be negative C0 and C0. And so that means it's going to be somewhere on the x-axis where we're going to have our foci. And so if you remember on the geometric definition, we said that the distance from that point to in those 2 points to any single point was 2a. And so that means this distance right here is going to be a, and this is going to be c. And then it turns out we can put a b in here, and so we get this Pythagorean theorem, which is a squared equals b squared plus c squared. And then from there, because of the way this is going to work, the distance from the center to a point on the ellipse on the x-axis, that distance is going to also be a. And the reason that it's a is because the distance from the center to these points has to equal 2a in both the two directions. And so it works out nicely that it just turns out to be a. So the first way we do it is we end up with x squared over a squared plus y squared over b squared equals 1. And then we have these things that we call the major axis and the minor axis. The major axis is the one that's longer. And it turns out that in this case, in the endpoints of the major axis are negative a comma 0 and a comma 0. And then the endpoints of the minor axis are 0 comma b and 0 comma negative b. And these 4 points are the 4 points that we're going to use to actually draw our ellipse. And then if we do the same thing, but if we make the foci on the y-axis vertical, so it's exactly the same thing, except now we have this. The only difference is going to be that the b squared is going to be under the x and the a squared is going to be under the y. And the best way to think about this is just which one's bigger, right? If you think about this, a squared equals b squared plus c squared, a squared has to be the bigger of the two between the a squared and the b squared. Thus, a is bigger than b. And that tells you whichever the bigger one is, that's what the major axis is. So if you're given a problem where you says graph, and the kind of one of the most basic ones would be this right here. So this is in the form of an ellipse because you have a positive x squared, a positive y squared, and we've got it set equal to 1. Well, in this case, your a is going to equal 3 and your b is going to equal 2 because a is 3 squared and b is, or 4 is 2 squared. And so then the way we graph this is, well, the major axis, it's under the y, and so it's going to be vertical. And so you're going to have 3 comma, or 0 comma 3 and 0 comma negative 3. That's the endpoints of the negative, the major axis. And then the minor axis is going to be negative 2 comma 0 and 2 comma 0. And so your ellipse is going to look like this. That's what your ellipse is going to look like. And then the other thing you have to find is your foci. Well, your foci are just going to come from this. And remember, your foci are going to be 0 comma c, 0 comma negative c. And so we do 9 equals 5 plus c squared, or 4 squared, 4 plus c squared, because a squared is 9, b squared is 4. And so c squared turns out to be square root of 5. And so your foci turn out to be square root of 5, or 0 comma square root of 5. And 0 comma negative square root of 5, because the foci are always on the major axis, and in this case, the major axis is vertical. So if I am given a problem like this, where I'm asked to graph something like 5 x squared plus 9y squared equals 45. Well, note, when we do the ellipse, it's got to be equal to 1. And so you always want to start by making sure that your ellipse is equal to 1, your equation. And so right now it's equal to 45, so I need to divide through by 45. And when I divide through by 45, that gives me x squared over 9 plus y squared over 5 equals 1. As we go through and determine the things we need to be able to graph this, our a value, or the major axis, is going to be 3. B is going to be square root of 5, because it's, remember, it's x squared over a squared plus y squared over b squared. So if b squared equals 5, then b equals square root of 5. So from a graphing perspective, that means that you're going to have 0, negative, or negative 3, 0, and 3, 0 for the endpoints of this major axis. They're along the horizontal this time, because the bigger number is under the x squared, and so that's the major axis. The minor axis is going to just be square root of 5, so just a little bit more than 2. And so it turns out the ellipse is going to look like that. And then the foci, well, C, remember, it comes from a squared equals b squared plus c squared, and so it's going to be 9 equals 5 plus c squared, and so c turns out to equal 2. And so your foci are going to be 2 units away from the center, and it's going to be along the major axis. The major axis, remember, is horizontal, so it's going to be 2, 0, and negative 2, 0 are your foci. So when you graph this, you basically need to identify 6 points. Endpoints of the major axis, which in this case are negative 3, 0, and 3, 0. Endpoints of the minor axis, which are 0, square root of 5, 0, negative square root of 5. And then the foci, which in this case are negative 2, 0, and 2, 0. Okay, when you look at them, sometimes you might need to do a better job than what the problem gives you from a scale perspective. So for example, if I had one that looks like this, x squared over 4 plus y squared equals 1. Well, and not x squared over 4, 4x squared plus y squared equals 1. Well, the problem here is we've already got it equal to 1, but we don't have any denominators. And so in this case, we know that the y is going to have a 1 as a denominator. But the x, since I've got 4x squared, the way that you actually would create this is by rethinking about it as x squared over 1/4. And so this is what it would actually look like. So in this case, your a would equal 1, because 1 is bigger than 1/4. And the b value would equal 1/2. So what I'm going to do is I'm going to make each of these, let's just say, we'll say that this, these right here, we're going to get rid of, and we'll let each of them equal 1/4. And so we're going to call this 1, this 2 here. So negative 2, negative 1. And so 1 and 2. And so 1 and 2. And negative 1, negative 2, so that we have a better sense of how to graph this. And so that the a is over the y, so it's going to be up here. That's where 0, 1, and 0, negative 1, the endpoints of the major axis. And then the endpoints of the minor axis are 1/2, which would be here. And so the graph of the ellipse would look like that, right? 0, 1, 0, negative 1, and then 1/2, 0, negative 1/2, 0. And then we need to find c. Well, c is going to be 1 squared equals 1/2 squared, which is 1/4, plus c squared. So that gives you 3 over 4 equals c squared. So when I take the square root of that, I get c equals the square root of 3 over 2. And then the bigger axis was the y. That's the major axis. And so that's where the ellipse is. So it'll be 0, 3, 2, square root of 3 over 2, and 0, negative square root of 3 over 2. That's going to be your foci. Okay, if you're asked to find the equation of an ellipse, if you're given the endpoints, and so if the endpoints of the or the x-intercepts and the y-intercepts, and so let's say the x-intercepts are plus or minus square root of 7, and the y-intercepts are going to be plus or minus 3. And it says, what is the equation of the ellipse? Well, if that's the case, recognize what this is saying. So the x-intercepts are square root of 7, so they're somewhere right around in here. Y-intercepts are 3, and so your ellipse looks like this. Well, remember the distance to the endpoints of the major axis are going to be a, and so in this case it's 3. And so you're going to have y squared over 3 squared, which is 9. And then the x squared, because that's in the x direction, is square root of 7. So square root of 7 squared is 7. So it just turns out to be x squared over 7 plus y squared over 9 equals 1. And so it's a really pretty easy given that information. And then the last type of problem you can have is one where you're given the foci. And so if you had the foci are 0, -5, and 0, 5, and then the focal radii, which is the distance, that sum of the distance, which is always going to be, so the focal radii is always 2c. So you're given the foci are 0, -5, and 0, 5, and the focal radii is 2c, is 20. And so that means that c equals 10. The foci are always on the, and so they're always on the major axis. And so the major axis is going to be here. Okay. And so actually it's not 2c, it's 2a. Sorry about that. And so a equals 10. And so this is the length of the distance from the center to the endpoint of the major axis. And remember, the major axis is where the foci are. And so our major axis is going to be in the y. And so we know that we're going to have, when we find this equation, it's going to be the y squared over 100, because it's y squared over a squared. And so the x squared is going to be over b squared. So we have to find that. Well, the way we find that is, we know that c is going to be 5, and so it's going to be 100 equals c squared, which is 5 squared, plus b squared, because a squared equals b squared plus c squared for these problems. And so that means that b squared is going to be 75, so b equals, which is actually all that we need to know for this problem, because it turns out that all we need to find out what b squared is. B turns out to be 5 root 3. If you're asked to graph it, then you would need to come over here to 5 root 3, which turns out to be like 8.5. And so the graph of this particular one that's being described would be like this. But the equation is just going to be that x squared over b squared plus y squared over a squared equals 1.